Our hands allow us to do some pretty incredible things. But have you ever thought about where they came from or how they came to be? Sir Richard Owen was a British anatomist in the mid-1800s who pondered these types of questions. And in doing so, he would be among the first to recognize an important pattern in the seeming disorder of life's diversity. Our arms and legs, as well as our hands and feet, fit into a larger scheme. The pattern of the human skeleton is one bone in the upper arm called the humerus, two bones in the forearm called the ulna and radius, a bunch of little 8 bones in the wrist called metacarpals, and a series of 5 rods that make up the fingers called the metacarpals and the phalanges. This pattern is similarly found in our legs and feet. By comparing this pattern to other skeletons of the world, he made a remarkable discovery. All creatures with limbs, whether those be wings, flippers, or hands, have a common design. One bone, followed by 2 bones, would attach to a series of small blobs which connect to the fingers or toes. This pattern, or formula, underlies the structure of all limbs. So where did it all start? To find out, we have to look at the fins of fish. At first glance, fish fins don't have any obvious similarities to limbs. They are largely made up of fin webbing and don't follow Owen's bone pattern. The base of a typical fin has 4 or more bones inside. It was not until the discovery of the lungfish, who happened to have a single bone in the fin base that attached to the shoulder in the mid-1800s, that the idea of starting to look at fish for evidence of limbs came about. Over the last 150 years of professional paleontology, the fossil record has provided us with some pretty good understanding of limb origin and how its development progressed. So let's travel back in time to about 380 million years ago, to the fish known as Eusthenopteron. This fish had the first evidence of the one bone connected to 2 bones, but it was still very much a fish fin. 375 million years ago, we had Tiktaalik, which many consider to be the first owner of a true limb. Part fin, part limb, Tiktaalik had fin webbing outside, but a primitive 1-bone, 2-bone, many-bone arrangement inside. This fish had a shoulder, elbow, and wrist, composed of the same bones found in the upper arm, forearm, and wrist in humans. These special features allowed Tiktaalik to do, of all things, push-ups. With its hands/fins lying flat against the ground, Tiktaalik could easily navigate the shallow streams and bank mudflats of its ancient habitat, as well as avoid potential predators in the water. 370 million years ago, we had Ankylthrostica, which had a flipper-shaped limb with no fin webbing. Additionally, the limb followed Owen's formula of 1 bone, 2 bone, many bones, and for the first time, fingers as well. This unique fin shape suggested this limb evolved to help the animal swim rather than walk. 365 million years ago, there was Ichthyostica. It had a fish-like head and tail, but also had fully formed limbs complete with powerful upper arms and legs and distinct fingers and toes, as well as vertebrae that were very amphibian-like. It would not be until about 250 million years ago that we would see the first complete penadactyl limbs, which included the full set of wrist and ankle bones, as well as 5 digits or fingers in some of the first reptiles. This final form would lead the way to what eventually would become our hands and feet. From these basic components, and over the next 300 million years, countless variations on this original theme would occur, continuing the cycle of becoming more and more specialized, yielding hands, feet, arms, legs, flippers, wings, hooves, and paws. All the animals that share this original bone structure have what we now know as homogeneous tetrapod limbs, meaning that they have 4 limbs similar in position, structure, and evolutionary origin, but not necessarily similar in function. The differences between these creatures lie in the difference in the shapes and sizes of the bones and the number of blobs, fingers, and toes. Despite radical changes in what limbs do and what they look like, this underlying blueprint is always present, allowing them to act as a living history of not only their species, but all of the previous forms that fought for survival and passed their adaptations on to the next generations. Hands have come a long way from their original inception, and we use them for so much more than basic survival. They can now symbolize strength, unity, and humanity. The hand represents a viable connection between all of us, and they help us to communicate in ways like never before.